God, I slipped this through. Whatever. Yes, I pass gas in here just to annoy you.
I'm joking.
Out, Stephanie and Stephanie. All right, what types of matter have motion? Oh, I had about 4 people get that wrong on the test yesterday. Now, some of them were absent when we reviewed it Monday and clearly had not watched the video.
I didn't watch it.
You were one of the people who got it wrong. All right?
No, I remember what I figured it.
See if memory fails me. It may not have. It may have.
Most of this question?
I put all because I remember we was talking about the desk. I don't know why.
Are these most of this question?
Yep.
According to kinetic molecular theory, which substances are made of particles? All matter except solids. All right. Describe the arrangement, motion, and attractive forces of a solid. What can you tell me about their arrangement?
They're close.
I want fixed what? Geometric. Yes. They have a fixed geometric pattern. But also tell me they have a crystal lattice. But I want a fixed geometric pattern. Okay? If I have a quiz tomorrow, which I've already told you you're having, you need to be able to tell me it has a fixed geometric pattern. All right. Yeah, there's no internet connections. There it is. Stupid. Now, open up and give me my attendance. Thank you. Stephanie, Jaden, Darlene,
I need a nap.
Dayton, Andy, Samaria, Tiffany, Ashanta, Celia, Karen, Jonathan, Eduardo, Jade, I see you. Marker here, Sophie, Marissa, Tomas, Abraham, Xavier, and Freedom. Everybody's here today. All right. So, what can you tell me about the motion?
Not bless you.
What can you tell me about its motion if I ask you? It vibrates only. What can you tell me about the attractive forces? It's the strongest of the 3. Why would they be the strongest? They're the closest together. All right, what are 2 properties that only solids have?
Solid is solid.
If you tell me that kind of crap on the quiz tomorrow, that's wrong.
Shape.
What kind of shape? Definite shape. You may have said the first time, I just didn't hear. All right, definite shape will certainly work. Give me something else. It only applies to solids.
Solid.
No, is it not compressible?
All right, I would take not compressible. Liquids are relatively incompressible, but not compressible, I would certainly take as one that would fit there. What else? There's one that fits the definition of solids that I need. I will take it, but all of them have a density, so that's not one I would like. All solids, liquids, and gases have a density. I want something that's unique to solids. Hope this quiz tomorrow is not for response. Y'all are going to be toast. What'd you say, Xavier?
Definite melting point.
That's the one I want. All right, definite melting point. All right, solids melt. No other state of matter has the ability to melt. Okay? Number 4. Why do gases have the weakest attractive forces? They're farther apart. They're also moving the what? The fastest. Which means their fast motion and their distance from one another, they have the least ability to attract. All right? We've already answered number 5. What's the only type of motion solids have? They vibrate. Okay? Number 6. What types of molecules have good surface tensions? We didn't get to this. We got to it in 3rd period. All right? Liquid molecules are either polar or non-polar. Which ones do you think would be more likely to have good surface tension and stick together and be able to mound in that round ball that I was able to show you? Polar molecules have good surface tension. Okay, non-polar molecules are not going to be able to stick together and form good surface tension. All right, questions about anything in the open? All right, talk test papers. Everybody took it except Jade, so if she's taking it, she's just, it's in transit between there and here. High score was Andy in both classes.
What was it?
98.
Ooh.
Oh, I had one for you. Maria. Sophie. Shanta. Marissa. What did you work on?
Don't give it back.
Anything circled is a total for the page.
Can I make me a bracelet?
Whatever you did there, that's the wrong answer. So I was trying to demonstrate what is the right work, but that answer is wrong. So I'm not sure what you did. All I did was write the right work. So maybe you can figure out what you did. Oh, H is -1. I know. I was so sure you had 100 and you did that stupid stuff right there.
Oh! I have seen worship here. I have seen worship.
Yeah.
No, do not waste my stuff on bracelets.
Just a little one.
I even tried.
I gotta see.
All right, look at it. Don't put it away. You're giving it back to me. Let's turn it down.
Oh, because there's 3 H's. That's what it is.
We balanced that equation so many
Why is there a
times
check
in class,
on
and then you balanced it wrong on the test.
Yeah. Which one? Oh, well.
Like I said, I was sure you had 100 on that. And I was going to be able to tell Xavier I curved the test.
You should.
I was so sure I was going to be able to use that line. And then you blew it.
Come on now, Andy.
Oh my God, I knew.
Because he balanced the equation wrong.
But it had a curve.
He wasn't going to get a curve. It was going to be a 0 curve because he was going to make 100.
Well, the rest of them.
And you're only going to get 2 points anyways, but I'm not curving at 2 points.
2 points is a lot in a grade book.
Not on this.
So why does 1 plus innocent?
Why does what?
I knew I balanced it.
Oh, anything circled is a total for the page.
Oh.
Okay? And the circle can be anywhere on the page. I don't ever pay attention to where I circle the minus whatever. It's just wherever there's an open spot on your page. If there's no open spot, I just wrote it wherever. Okay, but anything circled is a total for the page. And I grade page 1 first, then page 4, then page 2, and then page 3. Yes, ma'am.
Okay. So this,
Mm-hmm.
it says missing the low margin.
Yep.
Wouldn't that just be 1/1?
In that case, no, because you're supposed to ammonia to hydrogen. So it'd be a 2-3.
Did you get some?
Because you have 2 moles of ammonia.
What was the answer to number
You have
8?
2 moles of ammonia here to 3 moles of hydrogen. No.
Miss Wall, what was the number? I mean, the correct answer to 8.
Equal volumes of diatomic gases under the same conditions of temperature and pressure containing the same numbers of molecules. That's Avogadro's principle.
Can you explain number 7?
Yeah.
Because they take to.
Let me go grab a test since you all have your test.
I just need to use mine.
Good. I know what you made.
Brazil.
I get beat up. You look at my score on the split.
More than a sentence. That's not the worst way of that. Oh, you're right. Did? For the cities? No, that was France. That was Italy, yeah.
Italy.
It's 2002 there.
All right, number 7. It says we have what? Nitrogen gas collected by water displacement. So since we're collecting by water displacement, we have to use what formula? We're doing 7.
I got that right, and I did. I'm just sorry.
And the P,
Oh, Lord. You're using the P what?
T,
Equals?
He was.
Nope.
Oh.
You're using this one because
Oh,
it
yeah.
said water displacement, right? So it tells us what is the partial pressure in the question. So we want P gas since it said partial pressure. Where do I always find P water? On the chart, right? And it says the temperature was 20 degrees Celsius. So 20 degrees Celsius, and it says mmHg. To find 20 and mmHg, it's going to be 17.5. So I know 17.5 is going there. And the other temperature, or sorry, pressure has to be 730 because that's what they gave us in the question. So in math class, how do I solve for that? Subtract 17.5 here, subtract 17.5 there. So when you do that, and you get, what's that going to be? 7 what? 712.5 when you subtract those. Now, I would like to point out number 11, though, while we're talking, because I lost track of the number of people who did this stupid stuff. All right, in number 11, I gave you 2 ATM equals is the total pressure, and then you guys had a partial pressure of 685 torr plus 778.9 kPa, and I asked you for a partial pressure. And I don't know how many people, but a lot, probably close to 10, said this was 0.901, this was 0.778, and this. And then they added, and they got, I forget what it is, 1 point something. Here's my calculator. 1.6?
Yes.
That'll work. All right, 1.6, because I don't need the whole number. Plus P equals 2 ATM. And a lot of people didn't write all of this out, but this is the part that got me. Mm-hmm.
Oh.
They did. And out the side, I wrote that a lot on your test papers yesterday. All throughout the papers. All the chemistry stuff was right. Plugged in numbers like this, all throughout the test paper. And then the cross multiplying, the dividing, this stuff, the subtraction, y'all ran amok. I can't fix that at this level, okay? That's not my job at this point. I mean, we've worked these problems over and over and over, and I feel like I've done a decent job showing y'all how to cross multiply and divide. But on the test, would y'all just go crazy? This is a what? What's the opposite of plus? Minus. Okay? When y'all start dividing with plus signs, I just don't know what to do with that. Okay. Well, I'm not going to be very kind when I grade. That's a standard deduction. It's sort of like converting wrong. And I don't know how many of y'all left stuff in milliliters. If it uses R, what unit does pressure have to be in? Pressure has to be in atmospheres, which most of y'all did. That one was pretty good. But it's the volume one that I lost count of. Pressure has to be in ATMs, which we did. But volume has to be in what? I swear, people just left it in milliliters all over the place. Every time you did that, it was like in question number 21. Look at 21. It doesn't matter if you use PV or Big M. I had a mix of those. Left it in milliliters. Question number 20. Most people use Big M because I asked for molar mass. They left it in milliliters. Question number 19. You had to use PV, although I had a whole bunch of people use Big M there. All right? It's still got to be in liters. Now, can we go in number 19? If you use Big M, can you go from gram to gram in a two-step chart? while we're reviewing stoichiometry, can you draw a chart that goes this way to this? Did we ever draw any of those?
No.
Why do you think we could on this test?
They crazy.
Yeah, they are. How many steps do we need to go grams to grams?
4.
Yep. And you could have done this. And if you'd have gone grams to grams this way, it would have been beautiful. But you have to draw a 4-step chart to convert grams. You can't draw a 2-step chart and do grams. This part's wrong. That's what made your problem wrong. This would have made the way you did it right. Okay? But those kinds of things ate you up on the test in points. That's why people who thought they had 90s and 80s wound up in the 70s and 60s range. You can't make those kind of careless errors and expect to do well. Okay? Questions? Anything else on the test you want to know about? Anything?
No.
All right, let me hand them back. They're not coming out of the grade book. Hopefully it will not be your last one, but it is possible.
We keep these.
Nope. The good news is, if it is your last one, for those of you who have your bathroom points, it would go on this one. If you have them, it's 5 for each one you have left. So if you have all 3, then you have 15 points. If you only have 1, you have 5. If you have 2, you have 10. If you have all 3, of course, it's 15.
How many do I have? 3.
That one? The answer's wrong. So the work's right, so my guess is it's calculator. I spent every 10.6. So I don't know what you did wrong. Because the way you have it set up is correct. So now I will not put bathroom points on your last test grade until literally the exam. Why is that?
We can see where we was at.
Well, because somebody will go to the bathroom as soon as I put those points on if I don't wait to the exam. So that's why I wait. Now, I will also offer extra credit with review as we get closer to the exam time. And you can earn bonus points on your final quarter average. Now, notice what I just said there. Final what average? Quarter. Now, half of you are going to swear that I said what average? Final grade. I didn't say final grade. I said which grade? Quarter. As in 4th quarter average.
How many points?
So what is
You will have a maximum of a chance at 2 points. So if you have an 89, you can get up to a 91. If you have a 68, you can get to a 70. Because I will offer 3 review sessions. Okay?
I like how she said.
So that technically means you get 1.5 points and it rounds to what? 2 points. Now, if you only come to 2 of the 3 review sessions, you get how many points? You only get 1 point. So coming to all 3 gets you how many points? 2. Okay. Just making sure for those math wizards out there who weren't paying attention. Some of you won't come to any of them, and that's completely your option. All right, so on what the heck day was it? Monday. We talked about solids, liquids, and gases. Today, we're going to talk about phase changes. It's a hot topic. So what?
I was just saying, I remember one of the 7-point scale.
And be thankful y'all are not on the 7-point scale, or there'd be a whole lot of F's in here.
Oh.
Wait, what was the F?
7 below 70.
Whoa.
Oh.
Yeah, I had a whole lot higher failure rate back then.
Boy, yeah, I have
Some people would still be an A. There was a lot less of them on my roster back then. Now, phase changes. What's a phase change?
change.
Okay, a change in what?
Change.
Change in state. Okay? A phase change is a change in state. Now, when we say state, I usually get some smart butt who tells me North Carolina, South Carolina, Tennessee, something stupid like that. We're talking about solids, liquids, and gases. Any of you want to talk about plasma? We're not having a conversation about plasma. It's not part of our curriculum. I don't care about it. I just don't. Now, we're going to talk about 6 phase changes for the purposes of our curriculum. The 6 that we're going to talk about. Can you name any of them?
Solid.
The change.
Oh, evaporation.
All right, I'm going to change that to vaporization because we're going to need to broaden your horizons about that one. What's the opposite? All right, condensation's the opposite. All right, I need 4 more.
What's another thing in the water? Heatization.
Freezing.
Freezing.
Boiling.
All right, boiling fits under vaporization here. Let me just write boiling and evaporation here because those 2 fit under vaporization.
Liquidation.
You are creating some fabulous words over there today. We've had liquidation, and what was the other one? Heatization. That was good. All right, what's the opposite of freezing? All right. Now, the other 2, we don't even teach in physical science right now because they've taken out of the state curriculum. Why? I have absolutely no idea. It's not like they're so hard we can't learn them, but they've removed them from the curriculum. These 2, one of them, if you had a pretty good 8th grade experience, you probably learned. The other one, almost nobody teaches in middle school. All right? One starts with an S, one starts with a D. Sublimation is the other one. All right? Does anybody know the one that starts with a D? D-E?
Ionization. Deposition.
It's called deposition. Okay? Now, and I put them in pairs because they're opposites of each other. Now, today, we're going to talk about the definition ever so briefly because you should have learned the definition in 8th grade. Now, if you didn't, have no fear. We'll review the definition because if you're in Tiffany's science class, she had a sub, as she's told us many times. Now, we also have to learn to find it on a graph, and we have to know if it's endo or exothermic today. Those 2 things are my curriculum, whether it's endo or exo, and reading it on a graph. You also have to be able to calculate the amount of energy lost or gained today. Those 3 things are the new piece you're adding in today. Now, it's also what our lab is going to come from on Monday. So, since some of you are going to be in and out the rest of the week because you're going to be testing, I want to go ahead and give you your lab paper because you have to do some pre-work ahead of time. All right? If you don't do the pre-work ahead of time, you don't get to participate Monday.
Wait, what's Monday?
Today we're going to do the lab. Okay? Because I know I'm going to have several people out Friday who are doing AP testing. So, one short? I'm going to have enough for some more. Apparently I can't count. Y'all can't subtract and divide, and I can't count. We're a mismatched breed. So I got 1 extra now.
They usually give me 4.
Did I give you all some?
No.
There you go. All right. So the lab we're going to do is a specific heat lab, which we talked about way back in the day. Okay? And some of you are going to be like, oh, yeah, I remember that. Some of you might remember the word and be like, dang, I don't remember how to calculate that. Have no fear. We're going to review it when we get back down there to Q because we're going to add in 2 new Q equations, and we need to make sure you know how to do the old Q equation. Huh? Yeah. So, did you keep your old lab paper?
Yes.
I hope so, because this lab format you need for this lab report that's going to be due on Tuesday. Okay? Yes. Name, date, title, purpose, procedure, yes.
So, we're gonna do the lab Monday, and then we're gonna do the lab.
The lab report will be due Tuesday. Now, in order to participate, this little lab sheet right here that I just handed you, can't take it to the lab counter. Okay? Everybody hear me say? Cannot take this to the lab counter. Stephanie's looking at me like I'm crazy. Has to stay over here on her desk in her notebook. So how are you going to do the lab if I won't let you have the lab?
You gotta write your lab report.
Got to write down at least 2 things. You don't have to write the whole lab report. What 2 things you have to have written out to be able to go to that counter? Procedure, don't care about the materials. I'm going to have them already on the counter for you.
Yes.
Data table and the procedure.
The procedure.
If you don't have those things, you can't go to the counter. So if you come in here on Monday and you go, I didn't write mine this fall, where do you get to stay?
It's up there.
Sit down here in the chair. Yeah, you don't have to write it. You can take a 0. I don't have any desire to stay after school. However, if you want to make it up, I will give you the opportunity to make it up. Makeup day, the day of the walkout. So Wednesday after school. Because it's the only day I have next week to do makeup work. It's the only day
Right.
For a teacher.
y'all pay attention to any kind of news.
Wait, but y'all not doing that, are you?
How many of y'all
Y'all
are
not
in
doing
the
it.
U.S. issue?
Well, that's nothing.
But y'all not doing
How many of
that.
y'all have taken time? Come on, pay attention to your world.
But y'all not doing it, are you?
No.
I'm not personally, only because my world is not involved around those things.
Mr. Thompson said,
Doesn't mean people aren't going to Mr. Christ said let's go to school.
We can't.
Doesn't mean people are not gonna be.
Hey, I get another one in the papers.
You lost the lab sheet already.
No, the one from the other one telling you that. Right, left.
You think I have any lab sheets from that left?
I don't know if you do.
I don't.
Maybe you got extras. You're supposed to be prepared for these type of situations.
You want me to be prepared for children who lost their supplies.
You didn't tell us to keep it.
I told you we were gonna write 2 more lab reports,
But you didn't
and
tell
I
us to
scaled it
keep
back
it.
to only 1.
You didn't tell us to keep it.
I will see if I can find something in my archives up there that have the lab format maybe to put behind the opening tomorrow for you. Now, my point is that if you don't do your homework on Monday and you can't participate with the rest of us, I've built in an opportunity for you to make it up. Okay? You should be absent on Monday because you can't be here because you're sick, you have something else important going on, or you just lay out school because it's a nice day. Or whatever. You didn't do your homework. Your opportunity to make it up is when? Wednesday after school. If you don't come Wednesday after school and you didn't do your homework on Monday, I guess you just keep it a 0. Are we all okay with that? Yeah. This is not hard. There are how many steps? 11 that you have to write down. Now, it was really nice today when we could type, but you know I've had Google Share happen one too many times since made me mad. Now, there are 2 data tables. There's one on the front, and for those of you who never turn your paper over, there's one on the back. Because you've got to measure masses and you got to measure temperatures. Okay? Everybody okay with that? Just check. Those 2 things you have to have with you when you come to class on Monday.
Do the data table and the purpose.
You got it? Now, if you want to go ahead and do name, date, title, purpose, procedure, and the data table, so you've got that part of it done, all means, go ahead.
Is this gonna be our data table that we used to provide for?
Yes, I provided the data table this time. I provided the procedure this time. You don't have to create anything. I give it to
Provided
you.
everything.
I provided everything. Yes, it has to be. Now, for Monday, I don't care what color it is or anything else. When you turn it in on Tuesday, it has to be in blue and white. Okay? You have a question? Anybody else have a question? Yes, you're pretty much copying Slick. You could ask me. I answer questions too. He's not your go-between. I promise I won't yell at you. I only yell at Xavier.
Young
You need to come to 4th period. I'm not even yelling yet.
That's just because Malachi gets 4 things.
Probably. All right. You found what? Maybe you should share it with Xavier. If you feel kind. He could write it down. I wouldn't give it to him. I'd just let him take a picture of it on his phone.
You want a picture of it?
Okay? That way he has it. You know, 'cause
It took me this long to find it.
just take a picture of it, Xavier.
Xavier, download the picture.
When they give it back.
Unless you're gonna lose my phone.
Well, with some of my students, I never know what's going to happen. All right. So, which one do you want to start with?
No.
Let's go down the
All
line.
right, we can do freezing. All right. Starting with freezing. Now, starting with what you remember from middle school, the easiest place. What do you start with what state in freezing? Okay, we already got some dissension in the crowd. If we freeze, you got to know what state you start with. So what state do we start with? You start as a liquid. You change into a solid. Okay? That's the part I would have expected you to know from the middle school. Okay? Now, the part you got to know from my class is whether heat is absorbed or released, whether it's endo or exothermic, and then we're going to place it on a graph, and we're going to calculate how much heat is lost or gained. Really?
Say that again. I was writing this down. Say that again.
No.
Yes, Andy.
It's about like freezing solid.
Oh,
How does
serious.
that work? Like they get harder. Like if you froze like chocolate, it gets harder. How does that work?
Get ready to talk about it.
Okay.
That's the point of the discussion today. I said, that part you learned in middle school.
Right.
So in my class, we're going to talk about, is this an endo or exothermic example? Does heat get absorbed or released? And you got to be able to place it on a graph and identify where it's at. And you got to calculate how much heat is lost or gained by the end of class. And it's on the quiz tomorrow. I just added that piece in. Already ran it off.
That's me.
By tomorrow. All right? So, if we start with a liquid, okay? You guys all know that the liquid particles look like this from our discussion on Monday, right? So, if we have to change it into a solid, oops, my solid's looking a little rough there. Let me fix that. I hate SpongeBob.
Oh my gosh.
You're so mean.
Oh my gosh.
Okay. Now,
I just watched the movie.
Carson, you act like Patrick. You never know what's going on.
Hey,
Maybe that's why you hate SpongeBob. We just called you
that is me.
You be clueless. What?
How many people have you had to get 100 on the final exam?
none.
And he does all the first time for everything.
Is it all multiple choice?
I've never finished the curriculum.
Oh.
Closest I've come is they only grade 40 questions. I think I've had 39. So, which is not bad.
Who was it?
I don't remember. It was
Not bad.
recently. It was either Kieran or Danielle. Remember, I'm not going to finish y'all's curriculum either. So,
So does that mean we're not going to know everything on the test?
that's exactly what I'm telling you. You will not know everything on the
You
test.
finished in science?
Most years, yes, but we're behind this year, so we won't finish it. In one section, I've just put
Have you ever finished?
physical science, yes,
No, I'm
chemistry
talking about
twice.
chemistry. Oh.
Twice. All right, everybody got it?
What's at the end of the group?
Acids and bases. So when you look at these two things, all right, this is a liquid, that's a solid, correct? Everybody's okay with this. So what do we have to do in order, and this is the whole thought process for all 6 phase changes. This is how you decide if it's endo or exothermic or whether heat's absorbed or released. How do you change from a liquid to a solid? Do these particles have to speed up or slow down in order to become that? Okay. Okay, so the particles have to slow down. So if the particles have to slow down, what has to happen to the heat? Does the heat have to be absorbed and taken in so the particles will go faster? Or does the heat have to be given off to the atmosphere so that they can slow down? It has to be released, okay? Okay? So, in order for the particles to slow down, the heat has to be given off. If the heat is not given off, they cannot slow down because they're still going to be warm. Okay? So, if the heat is given off, we write the heat in the equation. This is a yield sign, right? So, we write plus heat on this side. Now, as we go through our remaining curriculum this semester, these are going to become thermochemical equations, and we're actually going to write the heat in in an actual chemical equation with symbols of elements and compounds, and we're actually going to put numbers in. So anytime the heat is a product, okay? When heat is a product, is it released or is it absorbed? It's released, right? Let me write that. Let me fix my grammar. Heat is released. So based on the definition we learned, well, I guess it'd be about week 1 of the semester. What definition is it? Is it endothermic or is it exothermic? It's exothermic. So freezing would be what kind of change? Is what? It's exothermic. Okay? Freezing is an exothermic process because heat is what? It's released. It's given off. Now, the reason that it's exothermic is you have to get the particles to cool down. Heat has to be given off for those particles to move slower and get closer together and move into that fixed geometric pattern. What did we say water's geometric pattern would become when it changes to ice? What crystal lattice does it form? Hexagonal. Okay, remember there's 3 of them you got to know. All right, everybody got what they need. All right, so the opposite is melting. So melting starts at what?
A solid.
And it changes into a what?
Liquid.
So here would be the flip side. So you'd have nice, neat rows of particles. And you would want them to change into a liquid, right? So what would you need to happen here in order for a solid to become a liquid? Would the particles in a solid need to move faster, or would you need them to move slower? Faster, okay? In its state when it is at room temperature and standard pressure, like now, at this normal state in the room sitting on the counter. Okay, not in the freezer, not in a steam bath, anything like that. You didn't alter any of its normal conditions. Okay, so the solid needs to move faster. So if you need the solid to move faster, what would you need to do with the heat? Would you need to add heat? You would need to absorb heat. Okay. Let me say this. The particles must absorb heat. Okay? The particles must absorb heat. So where am I going to put that? If you need them to move faster, they need to absorb heat. Where's the heat going to be this time in regards to that yield sign? To the where? To the left. So we're going to put the heat on this side. Okay? So anytime you write a thermochemical equation, and I'm only going to write this time also, just like I wrote here. Okay? When the heat is a what? Only instead of saying product, I'm going to say what? What I write right here. Okay? So when the heat is a reactant this time, it means what I say, so I write it the same way. Heat is absorbed. And what does it mean when I say heat is absorbed? It's what? It's who?
Endothermic.
Endothermic. So, anytime the heat is on the left or the reactant side, That tells you the reaction is endothermic. So, if you see any kind of reaction and you see heat on the left, you know it's endothermic. So if I write something on the quiz tomorrow and I have the heat on the left, you need to know that's endothermic just because the heat is where? On the left. If you see a reaction and the heat is a product or on the right, you need to know it's what? Exothermic, because the heat is on the product side or on the right. Does that make sense? Okay, because eventually, does everybody have this up here?
No.
Okay, tell me when you have it, Xavier.
The pressure can cause state changes.
Yes, if you increase the pressure, the molecules are going to get closer together and you can cause it to change states. Remember, it's all about the order of the particles and where they are. If you get the particles closer together and you can make them orderly and cause them to be a fixed geometric pattern, you can get them to change states.
All right.
All right. So if you have a reaction, and let me just say this, you have NH, let me say this, N2 plus H2 becomes NH3, and I write plus 467 kilojoules, which we'll have towards the end of this unit before we take the test if we test. All right, if you have that, is it endo or exothermic? How do you know? That's exactly right. As soon as you can tell me the heat is a product, you know it's an exothermic reaction. Even though we haven't done anything with that reaction yet, when we get there in about a week, you should know that that's an exothermic reaction because the heat is on what side? It's on the right. Even though we haven't gotten there yet, when we get there, that's what it's going to tell you. Everybody with me on that? Okay. Now, vaporization. Now, again, this includes evaporation and boiling. And in a few minutes, we'll talk about the difference between the two. But essentially, this one has to be non-boiling. And I've told you a few things that makes this different. Evaporation can take place at any temperature. Here, let me move this down a little lower. Didn't mean to erase the whole word. Hand got a little heavy-handed there. All right, so this one can be any temperature. You're not going to have bubbles. And it's always going to heat from the top. Okay? So think about it. When it rains later today, you play today, Andy? Or tomorrow?
It's right. It's supposed to rain today.
No. I'm just giving you an example. You play today? When do you play again?
Why she get mad?
Friday. Let's say he plays Friday and it rains. Needs the courts to dry. Hopefully it's going to come out and dry the courts naturally with the sun. But if it doesn't, hopefully they'll just squeegee them off. The water will get thinned out with surface tension. Not surface tension, sorry, surface area. And then the sun will come out and it'll dry them, right? Yeah. What things help the evaporation? Well, the sun. Does the sun have a particular temperature when it's drying the courts? No. It's supposed to be in the 80s on Friday. But what if it was in the wintertime? Is it in the 80s? No. Would the court still dry?
Yeah.
Some of y'all said no. Would the court still dry?
Yes.
Yes. It will still dry in the 50s. It will still dry in the 30s. It will still dry in the 80s. So any temperature will work with evaporation. Any of y'all have to clean up in the kitchen after your parents cook dinner? Any of y'all have to help? I got a couple nods out there. My kids are old enough now, they hate it. I'm making them learn how to cook and work in the kitchen with me. They hate it, okay? So when they wipe the counter down at night, how's the counter dry? Evaporation, because God forbid any of them take the dish towel and dry it up after they make the mess, okay? Now, is my house at the same temperature every day? Nope. Depends on whether we grilled dinner or whether we use the oven or the stove. Some days the kitchen's a little warmer. So the temperature changes in the house. They dry by evaporation. Now, evaporation. Do you ever see bubbles in the water? No. If you see a puddle in the summer and there are bubbles in it, don't step in it. Okay? It also heats from the where? Top. Sun generally evaporates most things, or lights in the room. So all that heat comes from the top. Okay? So how is boiling different? Comes from the bottom. That's one. Okay? First of all, it has one specific temperature. There are bubbles, which is why I said, don't step in any puddles you see bubbles in them. All right? And it heats from the bottom. Because the only way you get things to boil is you have to do what?
Heat it up.
You have to heat it up. You have to provide the heat. It's not going to boil on its own. Okay? So those are two things that will help you try to keep in mind how evaporation and boiling are different. We're going to talk about the conditions you need to get something to boil. Okay? So there are also specific conditions for boiling that we need to talk about, which we will not get to until probably tomorrow, okay? But it will not be today. It may not even be tomorrow. It may be Friday before we get there. Because they're sort of detailed. They have to do with equilibrium, and until we've covered equilibrium, we cannot talk about boiling. All right, have I given everybody time to catch up?
Yes.
Yeah.
All right, we all there? All right, so when I talk about vaporization, what state is vaporization in?
Liquid.
And we change to a what?
Yeah.
Okay. We go from a liquid to a gas. All right, so if we start with my particles fairly close together, and we change to a gas where the particles are pretty far apart. Okay? How do I have to, what do I have to do to get from liquid to a gas? Heat it up. Okay? So if you can answer heat it up, you should be able to tell me what you have to do to get that in terms of being endo or exo. If you can process that, do you have to add the heat, or does the heat have to be given off? As soon as you can say that, you should be okay with this. Okay? If you said heat it up, that means add heat. All right? So if Justice says add heat, which side does the add heat have to go on? The liquid side. It has to be added over here, right? Am I the only person in the room who sees that, or are y'all with me?
We're with you.
Okay, Sophie's with me. What about the rest of y'all?
When it goes from like to a faster state, the heat would be on the left.
Yes. If you got to add the heat to make them go faster, it's got to be on the left. Yes. Okay. If you need them to slow down, it has to be where? On the right. It's got to give off the heat. Okay. So if you had to add the heat, what does that tell you? It is what? It is endothermic. Okay, because I'm not going to write the rules out again. It's on the left, it's endo. Okay, so the opposite would be condensation. What do we start with in condensation?
Gas.
Okay, we start with a gas, we become a what? We become a liquid. All right, so we start with gas. We become a liquid where they're much closer together. So what do I need to happen for them to become a liquid? Do I need them to get faster or slow down? They need to be slower. So if I need them to be slower, what's that mean? Okay, take heat away. So if I'm going to take the heat away, all right, that means my heat goes over here. Okay? That tells me it's exothermic.
Ask you that. Like, solid to become can a solid become a gas? It would have to become a liquid first. Then just
Gas to solid. I looked it up last semester because I didn't know any off the top of my head, but I'm old and forgetful. We had an water example last time. Let me see.
You know, it's not, everyone has the word. I heard it's worse. What? For real?
I don't know that kind of deposition in there. We can talk about sub-freezing air changing directly to ice. Mm-hmm. It doesn't become a liquid, it goes directly to ice.
You talking about like hail?
So so if it was water vapor, I mean, it was actually a gas first, and it went directly to ice. So I guess if it was cold enough, it would actually become frost, maybe, would be the closest y'all would see. If it was cold enough, the water vapor in the air might frost before it became water. Maybe the closest we might see here. Looking to see if they have anything else other than that y'all might see or know of. Let's see what other examples I have. Yeah, I know that. You see it on film. I don't want those on sublimation. Oh, that's sublimation, I know that. No, I put that film and. Well, on film and like frost. That's all I got. All right. The last two. Sublimation. All right. Can we do this one without the pictures?
No.
All right. This one is a solid to a gas directly. This is the one that these two, depending on who you had in middle school, you may or may not have actually talked about. All right. Solid. Okay. Look, I'm sweating over here, kid. You're gonna need to bring a coat.
Today in
And I am moving. I understand
in
that.
health science, we learned that Caucasian people have thicker skin and retain more heat. They retain.
They do. And I did go down to Jackson Academy and back right before class, and I am hot because I
That's
was.
why y'all
I
can wear
was-
shorts in freezing cold weather.
I don't wear shorts in freezing cold weather.
A lot of Caucasians.
My husband does. I admit that. And I've told him he's stupid. I can't fix that. Now, in order to change a solid directly to a gas, all right, what would I need to do? All right, a lot of heat, okay? We have to add heat to get this to happen. So, if we have to add heat, and it doesn't have to be a ton of heat, it just has to add heat. All right, what do we do to do this? What side does the heat have to go on, the left or the right? Okay. So, whoops, I changed the color there. So, plus heat over here. So if we add heat, all right, since the particles must go faster. Okay. So if we add heat on that side, that tells us this is what kind of process? Endothermic. Now, just to give you an example that you can probably relate to, some of you may not be able to. An example you might have heard of is dry ice.
Yes.
Okay, dry ice is solid CO2, and it changes into gas, CO2. So, they take carbon dioxide that we exhale, and they use temperature and pressure to literally cause those particles to get close enough that they turn into what looks like a block of ice. Okay, and we can use that to package and ship meats and things larger distances because it stays A, cold, and B, if it sublimes, does it leave a puddle under whatever you packaged, whatever ship? No, because it changes into a gas. Okay? So it works really well. Now, you can also use it, a lot of people use it for football in the fall because you can pour like water on dry ice, and what will it make? You may know?
Liquid.
Makes fog. Okay, because it will. It'll make a liquid. It'll make us, it looks like steam coming up with the CO2 mixing with it. You can use like dye and colors. You make blue fog.
Don't they make it like, don't they put that in like smoke?
Yes, that's how they do it with the dry ice. Yes.
What's liquid nitrogen?
Liquid nitrogen is just nitrogen that they lowered the temperature and pressure on to turn it into a liquid. But it's still a gas. It's gaseous nitrogen that they lower the temperature and pressure on. It's just turned into a liquid. No. No. Dry ice is carbon dioxide that we exhale, and they've turned it into literally a block of ice by pressure and temperature and changing the conditions.
You ever played with liquid nitrogen?
Yeah, never had the opportunity. Okay? Now, the opposite of this would be deposition. Okay? Deposition is the opposite, which is the one we just looked up and saw frost as an example. Deposition would be gas to a solid. All right? So you're just taking your gas that's all spread out, and you're changing it into a fixed material. So if you do that, what do you have to do to get that gas that's going everywhere into that fixed pattern? That's right. Okay. You want to take heat away because you want the particles to slow down. So if we want to get it to slow down and cool it, where do we put the heat? On the reactants or on the products? On the product side. So that tells us deposition is what? It's exothermic. So does that help with who's endo and who's exo? And how to figure out whether heat is lost or heat is gained?
Yeah.
If you have to heat it, it's going to be what? If you have to heat it, it's endo. If it gives off heat, it's what? It's exo. Okay, so now we have to learn how to read the graph, which is the easiest graph to learn all year. And then we got to calculate. Calculations are easy too. The whole day is easy, other than it sounds hard. It's not hard. The graph is easy.
How many questions is the quiz?
10.
What's the hardest thing to learn?
The thing that y'all will hate the most is probably the Chatelier's principle with shifting equilibrium.
That's what we're not gonna get to, right?
Next week.
Oh.
No, we'll get to him. I will be stunned speechless if he's not on your exam. Just telling you, he'll be there. You can pray the gas laws are not on your exam. All right. Now,
This is not natural. Natural disaster.
Now, I point out the name of this graph in that it's a phase change graph, because there's one we're going to learn probably Friday. It's called a phase diagram. Okay, this is a phase change graph. Now, the nice thing about the phase change graph is there are two phase changes that are not on there. Which two do you think are not on there?
Deposition and sublimation.
Exactly. Sublimation and deposition are not on the graph. So you will not have to worry about those two. Okay? Now, on the graph, you're going to have temperature over here, and you're going to have energy down here. The graph is stairs. The only thing about the graph that changes is how steep and how tall the stairs are. But it's always stairs. Okay? For the purposes of talking about this graph, I'm going to label the stairs A, B, C, D, and E, because those 5 sections are the 5 sections you have to be able to read about the graph. If you can read those 5 sections, then you're good to go on the graph. Okay? So, what can you tell me about sections A, C, and E?
You add E.
All right, they're being warned. Okay, they're going up. Can everybody agree that A, C, and E are rising? Okay. So A, first of all, is a solid. It's always going to be the solid at the bottom because it has the lowest temperature. Okay, so solid, and it's warmed or heated. Now, if the graph was drawn backwards, we would have said it was cooled, but it's being heated because it's going up. C is the liquid. And it's also heated because the graph is going up. All right, and E would be what state? Gas. You could say vapor too. Some people will say vapor instead of gas. It means the same thing. Now, the hardest part for people to grasp or understand about this graph are sections B and D. Okay? B and D are the phase changes. Okay? And I'm going to say this like 400 times. Temperature remains constant. Y'all are still going to answer it wrong on the quiz and the test. Now, look at that graph. What can you tell me about B and D? Are they going up or are they flat? They're flat. So temperature is not doing what? That's the part I need you to get about phase changes. Okay? Phase changes do not change temperature. Okay? And every year when I teach this, half my class still tells me that during phase changes, temperatures change. They don't. When it snows, what temperature do we need for it to snow? That's the freezing point and the what? What's the opposite of freezing?
Melting.
Freezing and melting point. Snow freezes and it melts at what temperature? 32. Okay? It's all one temperature. Okay? That's why it's a what kind of line? It's a flat line. It doesn't change. Okay? They're constant. Okay? So B is the melting point and is the boiling point. I'm sorry, not boiling point, stupid. Freezing point. Now, from here on out, what am I going to write as those letters so I don't have to keep writing those words out for y'all? MP and FP. Okay? Yeah, that's just B. Melting point and freezing point is B. Now, D is between a liquid and a gas. So what's D going to be? All right, condensation could happen in D. And vaporization. Now, you've got to remember what two things were vaporization?
Evaporation and boiling.
Evaporation and boiling. Okay? So your boiling point, and I'm just going to put it in parentheses right under it. I'm going to put BP for boiling point right under vaporization Because when we said vaporization, we said it was evaporation and boiling. It's both of those things. They're at D. Okay? But again, the temperatures don't change during a phase change. Temperatures change if you're just a solid, if you're just a liquid, or if you're just a gas. Does that make sense? All right. See if you really got it. We're going to read a graph. This is like super, super easy. This is a final
I
graph.
don't think I want to do it.
All right. Now, Xavier,
Oh,
I'm telling you now, since you claim I didn't tell you last time. I was trying to conserve paper.
Right.
So this is today's graph.
Right.
This will be used tomorrow. If not tomorrow, it'll be Friday. Don't use the paper.
so can I get another one if I do?
No. What?
Oh.
Because vaporization is evaporation and boiling. Huh?
Boiling point.
Boiling point.
Oh, okay. I thought you.
What's funny about them? I don't see them.
No. We don't use a letter for evaporation. We just write BP for boiling point, MP for melting point, and FP for freezing point. Yeah. And whose grab-and-go trash is on that counter back there? All right. All right. I want you to answer 1 through 12 real quick. This will take us like 5 minutes or less. Yeah, come on. If we got equilibrium vapor pressure and boiling point. Hey, answer questions. Quickly. We gotta learn how to calculate.
Write the letter.
If it asks for freezing point, it's not a letter. I'm just saying, it's not a letter, but asks for
No,
freezing
but I
point.
mean, you wrote it right there. It's right deep.
I told you because we were labeling the points on the graph, so you know what the graph was. Jade, you're answering that graph worksheet if you're listening.
Okay, anyways. Yeah. I don't get what this is. Right.
The melting point.
Now, you know what, I'm just wait. She said it was a freezing point, it was not a letter. What are we supposed to put in?
The numbers.
Say what?
Are we supposed to put like actual numbers?
If it asks for a freezing point, boiling point, yes. With the Celsius.
Solids.
Yeah.
Yes, Jaden. What she say, freezing point was 20?
You gotta read the graph.
It's based on the letters.
Based on the letters, you gotta look it up. Which letter was the freezing point?
What number is associated with B?
I'll just write it.
E.
I don't get a hug as well.
No.
I need one.
How many days have we been? I mean, that could be, right.
Crystallization is freezing, right?
Say what?
Crystallization is freezing.
Crystallization goes from a what to a what?
Liquid to solid?
Yep.
So it's freezing now.
It would work the same, yes. It's not technically freezing, but it would be very similar. If you ever made crystals or rock candy when you were younger, it would work the same way.
Oh, okay. Ready for it. I'm ready for something. Quit.
Yeah.
Oh my God.
All right, we got enough time?
That would hurt. I guess.
I really heard it.
I didn't say that.
I heard. I heard it.
I said really hurt.
The word.
Really hurt. You've been feeling yourself.
All right, so if we look at question 1. First question. All right, question 1. What's the freezing point? All right, you need, anytime it says freezing point, because some of you are like, Ms. Wall, do I write the number or the letter? If it says freezing point, the question says freezing point, it wants the number. If it wants the letter, it will say what letter. So, when you wrote your answer, none of y'all just wrote 5, did you? All right, 5 degrees Celsius is the answer. If you just wrote C, I'll take it. Celsius and Fahrenheit have degrees. Kelvin does not. All right, the next one wanted the boiling point. Boiling point would be what? 15 degrees Celsius. And then the melting point would be 5 degrees Celsius. Everybody good with those? All right, number 4. What letter represents the solid being warmed and the liquid being warmed and the vapor being warmed? All right, represents melting of a solid. B represents vaporization of a liquid. Are you okay over there? Oh, yeah. All right, vaporization is D as in dog. All right, now, I think it's easier to do 10 before we do 9, so look at 10. What letters represent change in kinetic energy? Kinetic energy is what? Moving. All right, what's kinetic energy based on? So they change based on the what? So where's the temperature changing? All right, so kinetic energy changes at A, C, and E because temperature changes at A, C, and E. Does that make sense? All right, so now go back to 9. Where is potential energy going to change? B and D. Does that make sense? Okay, now I will also preface the next test if we have it by saying this. I have no review sheets. Okay, these are your review sheets. So don't lose these. If we have it. Okay?
Come on.
Just telling you. Number 11. What letter represents condensation? D is in dog. And recrystallization. For those of you who did not have the opportunity to grow crystals, you start with a liquid and it changes to a solid. So that would be which letter? B is in boy. Okay? Now, the last thing we have to do today is to calculate. So, we got 20 minutes to learn how to calculate. So, calculations go with these 2 spots on a graph. Okay? Get rid of that. Pull that back. All right, so we're calculating Q. Or not. It's on the quiz tomorrow whether you can or can't. All right, so the 2 spots we have to calculate Q are the 2 spots I just labeled right there. Now, we have already calculated Q, and we're going to add in 2 more Qs. So when we look at this, all right, we're looking to calculate how much heat is lost during a phase change. Now, the thing that will be different about these calculations is it's a phase change. If it's a phase change, will the temperature change? No. Okay? Temperature will not change. That's what's going to make this calculation recognizable to you. Is it either won't give you a temperature or the temperature is only going to be one temperature. Okay? So, this first one is going to be for melting and freezing. This one is going to be for evaporation and condensation. So the formula we're going to need for the bottom one will be a heat of fusion, and the one we will need for the top one will be a heat of vaporization. Okay, so those are the formulas we have to learn how to use. The bottom one will be for melting and freezing, and the top one will be for evaporation and condensation, and we'll need to learn how to use heat of vaporization. Now, the nice thing about both of these formulas is they're on the reference table, and the constants are on the reference table. So there's no memorization to go with any of this. All right, is everybody caught up? Yeah. All right, so the parts of the equation. The nice thing about the parts is they're identical. Okay, the first one is Q equals MHF, and the second one is Q equals MHV. Okay, now we've already studied Q this semester, so we know Q means heat lost or gained, and it's always calculated in J, which stands for what? Joules. M is mass, which is in what unit? All right. HF stands for heat of fusion. I'm not going to define it because you're never going to be asked what it stands for, but essentially it's a constant. And it's on the reference table. HV, again, is a constant. It's the heat of vaporization. And it's on the reference table. If you want the definitions, I can give them to you, but they're really going to serve you no purpose. Because your exam is not going to ask you a bunch of odd definitions. It's going to ask you to use the formulas. Now, what do you notice is missing from this formula that specific heat had? T. There's no temperature. Why is there no temperature in this formula? It stays the same. That is correct. It's exactly what you should. When y'all remember stuff, I do get excited by that. Makes me feel like I taught something.
About did.
I about did. I was happy to use that word about.
I about remembered it.
Some of y'all are about smart.
That's wrong.
Probably is.
I'm gonna start bringing blanks.
Because you meant slang and I didn't. Miss Curry will have all kinds of fits about that, so
She not gonna see me.
Right.
she's not gonna see you in the blanket.
No, she's
Not in here.
Exactly.
Okay.
She's too short.
You know, because it's unsanitary. She's gonna tell them what kind of critters might come in
It's
the
not like I'm
blanket.
a dragging around like.
Right.
Right. You might like
I'm
I'm
a
dragging
dragon.
off of
I'm
turn
a
around.
dragon.
No. Am I book back?
Everybody got it?
Oh, wow. Yeah.
That's world.
Who is
It didn't line us?
No.
I thought it was light.
I thought it was too. He's all dirty looking. It carries his blanket. He has that puff of dirt dragging around.
I was right. Okay.
I thought it was Linus. I could be wrong though.
How much you selling them papers for this on?
All right. Google it later. I don't have time. All right. So if you have this question on your quiz tomorrow,
Want to
All right.
write it down?
it's up to y'all. I'll wait on you if you want to write it. Just write fast. We got to do 3 of them. Whoa. We got almost 13 minutes. Surely they're not going to ring the bell 10 minutes early for hot dogs and catch me unaware because, you know, I don't listen to announcements.
What, for the
They
teachers?
Yeah.
They didn't announce it because my teacher was like, when did they do this?
I had no
They announced
idea.
it.
We had
They
crap
did announce it.
everywhere.
They said that they were gonna let us out at 3:22 or something.
Yeah.
I don't know what it's called.
Nobody in this building knew Elizabeth's ballot. Man.
They announced it. People just don't be listening.
No, I didn't listen either. I admit it. I don't ever listen to that crap. It doesn't say anything important other than
Where is our
something's gonna
English
be
exam
Airbus
Friday?
something.
Where is it?
Isn't that the Methodist?
I thought it was the church.
First Baptist.
No, it's something Methodist.
Y'all is that church over there by the
What is
wall.
that?
That, yeah.
That's First Baptist.
First Methodist and First Baptist are almost the same.
Yeah.
One's here, one's here.
Ours
The
is
Y's in
right
between them.
I think ours is right there in front of the.
It's in Brooklyn.
Yeah, I know.
The Y is here,
First
Baptist is behind it,
Baptist.
Methodist is in front of it.
Oh, yeah, that one.
Yeah, the one with the basketball court.
That's the one.
So which way do we go in from the front?
All right, we got it written?
Yeah.
Xavier, you there?
The one
I'm
across
at the
the
end.
All right, so when you look at this question,
Yeah.
when you look at this question, how are you gonna know what to do? What stands out to you in this question?
Temperature.
All right, how many joules? They're all gonna say how many joules. That's not gonna help you. All right? All right, temperature, grams. What stands out about temperature and grams?
The number.
Which one is more important?
The temperature.
What about the temperature?
The Celsius.
All right, it's giving you Celsius, and how many are there?
2.
2. Okay? This right here is a temperature change. Okay? Because you have a temperature change, this is going to tell you that you want Q equals mCp delta T. This is our old question from way back in the day in the first week of the semester. Okay? That's why I put it up here. Not that any of you have forgotten, because you about remember, right?
No.
Not you. Okay. So what am I asking you to calculate?
The change of
The change. So which one of those? It says how much heat. So which one of those is heat? Q. Okay. What's mass?
15 grams.
Okay. Where am I putting that? 35 to 85. Where's that going?
Right there.
Yeah.
At the end for delta T. So what do I do with it?
You gotta subtract and find
The difference. Do I use the negative or just subtract and use a positive? Subtract and use the positive. So 35 minus 85 is 50 if I did it right in my head. Did I?
Yeah.
Okay. Now, where's CP going to come from? Reference table. This was killing y'all on the exam. When we took bench bars back in, I don't know, week 5. Y'all were like, Miss Wall, I don't know where the stupid number's coming from. Look on your reference table. You're going to need it. Find page 1. Right here where my fingers are. Okay? There's 3 numbers. It says thermodynamic constants. Okay, on page 1. Everybody see them? Except the people who don't even get out of the paper. All right, this bottom one says specific heat of water. Everybody see it?
Yeah.
There's 3 numbers in there. If my question says water, which one do you suppose I want you to use? The liquid one. So what's the specific heat of water?
4.8.
And so you're going to multiply and solve. Okay? So 15 times 4.18 times 50, and I got 3,135. And what unit goes on Q? Yes. And then you're done. Okay? That's the old question we learned how to do. Okay? Old question. Everybody with me on it? Okay? Now we're going to do the new version. I like that one.
I know we saw y'all watching this yesterday.
Yeah. Y'all were actually singing. All right, so if we look at number, right, this one, who was that?
Did you make your own this?
Right, what were y'all doing this morning? Write the question down while you tell me.
She was just yelling. Because they wasn't doing their face for the freshman grade.
Well, y'all's concert's coming up. She's not gonna be happy with y'all if you don't go right. Huh?
Are you gonna go to the concert?
The only time I can go is Wednesday. So it will depend on whether Ms. Rector has it Wednesday.
When is it again?
Yeah, I know, but if she goes to the walkout, she won't be there Wednesday, it'll be canceled.
This week.
Next week.
Right now, she's not planning to cancel it
Why would she cancel it? I don't think.
if she goes to the walkout.
Highly.
Ain't nobody going.
Right now, it's
Miss
highly
Rector.
doubtful.
It's Miss Rector. She ain't going.
If teachers, they don't move back graduation.
Yeah,
No,
everything
that's
goes
only-
next
that's only
month.
if they cancel school. If you're gonna go to the walkout, they said you can get a sub. Not cancel school.
No.
Hey, I'm fine with that.
I wonder what they're gonna do though, if enough teachers don't show up and they don't have enough subs.
They cancel school.
I'll be here.
Oh, no.
We know Miss Wall gonna be here.
I know Miss Rector's gonna be here. There ain't no reason to get my hopes up.
But mine's more about my personal schedule than the school schedule. I can't fix my personal life to work it. All right.
But Miss Rector's just that person.
So if you look at this question, what's different about this one and the one we just worked?
Water freezes.
All right, the word freezes is huge. Okay? This right here says this is a phase change. That's one word. That's one thing you look for. All right, next.
The zero.
One temperature. Okay? Those are the 2 things that tell you it's the new formula. That's the 2 things you look for. Now, the only question is, which one do you need? Is this a freezing and melting one? Or is this an evaporating and condensing one? So, which one went with freezing and melting? HF or HV? So you want Q equals MHF. So, what did they ask us to find? The Q, the M, or the HF? The Q. It says how many what again? Joules. What's the mass? 25.5. Now, again, go right back to where I was on this blue chart. Into thermodynamic constants. This is where the state and I disagree. There are charts and charts of HFs and HVs. They could change that compound all day long and make us learn to read these charts. State of North Carolina has decided the only liquid y'all are using is water. Period. So there's only one HF and one HV. Y'all can't screw this up if you know how to work the formula.
4.8.
Okay? So the only HF you're going to use, find heat of fusion on this chart. What's heat of fusion? 334. So you're going to write 334 right there. And all you have to do is what? That's it. So 25.5 times 334. I got 8,517. What unit goes on Q? Voila. That's it. You got this? Think you can try one on your own?
Yes. Yes.
It's not hard. All right. Try that. on your own. You can write it down if you want, but you don't have to.
Oh, the temperature doesn't matter?
Not if you only have one.
Okay.
But remember, phase changes, the temperature does not change. So you calculate or playing on your phone.
Holy crap.
I have a big number.
You're gonna get a big number for this one.
Wow.
Dude, this huge guy.
All right, we got a chance?
No.
What are you doing? Are you at least gonna put my beads back? Yeah. Thank God. Everything's still scattered everywhere because we didn't know the bell was gonna ring at any 3:20 yesterday. No. I told you we won't need that until tomorrow sometime. Yes, with this math. All right, so how do I know to use this formula? What words and what things in the question tell me this? Evaporates and what's this? One temperature, right? So my mass is what? 35.6. How do I know to use HV? It says evaporates. What is my HV? Now, I know several of you said this number's huge. You're just multiplying. It's going to be huge. So what'd y'all get? You got what?
80,000.
That. All right. Now, for homework. Homework. I know, it's terrible, isn't it? You only got 6 math problems. Now, your quiz tomorrow is on anything from Monday and today. Homework is 6 math problems. Should be a breeze.
You better do it.
I'll do it. I'll do it. She do it.
If you got a calculator, put it in the bucket.
No, I've never done that. I like
Wait, Dr. Dan.
it.